It's such a privilege to be part of this inaugural JSConf Mexico, so I'd like to thank the organizers for having me. Now today I'll be speaking on a topic that I know may not be everybody's cup of tea, and that's fine. I don't expect everyone to fall in love with CSS after this, but I do hope that you'll find some of the things I'll be sharing useful, and hopefully it will also aid in your understanding of how modern CSS layouts work. So let's get right into it. The first thing I want to cover today is something called content-based sizing. So the concept of automatic sizing has always existed since the earliest days of the browser, because browsers have always managed to figure out how much space content should take up without any intervention from us. Like the content would reflow without overlapping. You didn't have to write anything special for it, just part of the web. What we have in a relatively recent CSS specification, known as the CSS intrinsic and extrinsic sizing module, level 3, is the height and width CSS properties now can take 3 additional keyword values, which are min content, max content, and fit content. So the keyword here is content. So these widths, these keyword values actually give authors the option of assigning automatic widths to the elements on the page. So let's go through what this means, right? So the first thing we're going to cover is min content. Min content is the smallest size a box could take that doesn't lead to overflow. So if there's any inline content, instead of overflowing, it will break into multiple lines. Now, line breaking might be something most of us don't give a second thought to, but there is a lot of nuance depending on the language being used. For many languages, like say English or Mexican, line breaks tend to occur at word boundaries, where spaces or punctuation are used to explicitly separate words. And browsers will not break words by default. So in this first example here, the word content plus the full stop at the end is treated as a single unbreakable entity. And that ends up being the width of this first box. In other languages, though, specifically for the East Asian languages like Chinese or Japanese that utilize Han characters, the break is per character most of the time. But not always, because there are rules about certain characters that are not allowed to start or end a line. Now, East Asian scripts also use this thing called full width punctuation. So what this means is that if I add a full width, say, comma right here, this box is now 2 characters wide instead of 1, because in East Asian languages, the punctuation takes up the full width of a character. Now, we also have some other Southeast Asian scripts, for example, like Thai, which are written without any spaces between the words. So the text can be wrapped at syllable boundaries in addition to word boundaries. So before I talk about the Thai box, let's go into the second keyword value, which is max content, and it'll make things easier to explain. Max content is kind of like the opposite of min content, where it is the box's ideal size in a given axis if there's like infinite space. Like if there's lots of space, that's the size of the box that can fit the content perfectly. So content just takes up as much space as required to lay itself out on one single line. So for the Thai example, if you don't read Thai, like I don't read Thai, I wouldn't know where the word breaks would happen. But the word that is longest here is this word called prayok, and that is where the word broke in the min content box. And that's why that's the size of the min content box. But in a max content situation, everyone is a single line. That's the amount of space that's going to take up, and that's how max content looks like. Now there's a third value, fit content. Unfortunately, this is not a supported value right now, but all of these 3 keywords I just mentioned are supported when used in the context of a grid formatting layout. So let's look at this grid here. I'll highlight it. You can see I'm using display grid to do it. So fit content is not like a fixed value. compared to min content or max content, it is actually a range, right? It is a range between the min content size and the max content size of a run of text. It could also be a length percentage, because if you look at the syntax, it's actually like a function. So you can actually add a value inside the parentheses. This is pretty hard to explain in words, so I'm hoping that the DevTools can help me in this explanation. So this particular example here, we can see 3 columns that are sized with min content, max content, and fit content, respectively. So now if we look at this max content run of text, it is about 482 pixels. Now, when I resize the browser, the fit content box will shrink to a minimum size that is equal to min content. But if there's a lot of space, I'm going to expand the browser. It's going to keep growing until it hits 300 pixels, which is the value that I've put inside the parentheses. If you look at the code, I put a value of fit content 300 pixels for that last column, and that's why it stops growing at 300. Now say, if I change this 300 value to something greater than 482, because in case you don't read hard characters, all 3 columns have exactly the same run of text. I'm going to change this to 500. So 500 is longer than the max content of the text. But if I keep expanding the browser, you'll notice that it doesn't hit the value of 500 that I put in the parentheses. It will stop at the max content width. So that's how fit content works. It is the range between the min content size and either the max content size or the length percentage defined within the parentheses. So now that we've got these basics covered, I think we're ready to move on to the next section, which is about Flexbox. Now, Flexbox was the first layout model that was designed specifically for building web layouts, and it is a lot more powerful than the previous techniques that we've had. Flexbox allows the browser to take over sizing based on the amount of available space. So this can be quite confusing at first because the end result may not be what you explicitly set. For now, Firefox is the only browser with a Flexbox inspector, so let's take a look at this, right? So I'm using Firefox right now. If you go over to the Layout tab, you will see that there is a Flexbox option. And so I'm just going to highlight my first example here. In the inspector, you can either choose to activate this tab, or you could have chosen to toggle it. Either way is fine. But when the overlay is toggled, what you can see is the outlines of each Flex item and also the amount of free space available as sort of this dotted line texture thing. If you look at the layout panel, it will tell you the Flex direction, its wrap status, and more importantly, it tells you what the browser does when it grows or shrinks your Flex item. And I will talk about this a bit more in the examples below. What I find really cool about Flexbox is the amount of control it gives us over this distribution of free space. It's kind of a newer way of thinking about how we lay out our items on a page. Now, the sizing of Flex items does depend on a number of factors. So it depends on the amount of free space available, the amount of content within the Flex item, even the starting width of the Flex item. Now, the exact algorithm is sort of complicated, but it is outlined in detail in the specification if you're interested in how the calculations actually work. And personally, I feel that the key to figuring out Flexbox is understanding how the Flex basis property works. Say I put a fixed value of 100 pixels as the Flex basis of a Flex item. I feel that intuitively many people expect to see a box with a width of 100 pixels because we're so used to being in control of our sizing instructions. But Flexbasis is actually the starting point from which the size of the box is calculated. So remember that the key here is the starting point. Because if your flex items are allowed to grow or shrink, odds are the final size may not be whatever you put in the Flexbasis. So let's move on to this next section, Flexbox Basics. Because I want to talk about this scenario. I want to talk about the scenario where the same flex values could potentially give you different end results. So if we look at the content of my two examples here, 3 columns. First 2 columns have exactly the same content, right? This is a sentence, word, both have it. The only difference between these 2 sets of content, and let's highlight it to see. So both of these divs have the same styles on it. So if you look here, you'll see that both of these divs, they are set to display flex. That is all, nothing layout specific. Each of the flex items themselves are not styled explicitly, so this means that the flex items are taking the initial values. So if you look here, Flexbox actually has a number of keyword values that resolve to these, because flex itself is a shorthand, right? So it resolves to these values. The initial value of flex, if you don't do anything, the default value that the browser applies is that a flex grow of 0, a flex shrink of 1, and a flex basis of auto. And this is what we have in our first 2 examples. I'm going to come back here so you can see. So, I mean, it's totally possible to change the flex values, but by default, if you don't do anything, it's 0, 1, auto. So what this means is that flex items won't grow beyond their starting widths. So if I resize, you'll notice that it doesn't grow beyond the max content. But a flex shrink value of 1 means that all the items will start to shrink at the same rate if there isn't enough space for all the content to be on a single line. So if I start to shrink at about this point, the second set of content has to start shrinking at this point because there isn't any more free space. So everybody who can shrink has to start shrinking. So when I presented this example, I think it was somewhere here, the second column had already shrunk quite significantly, whereas for the first set of examples, plenty of free space, no shrinkage required. So even though the same flex values are applying on both of these examples, you'll notice that the size of the second box completely different, right? So let's talk about Flexbasis in this case, right? The initial value of Flexbasis is auto. And auto typically resolves to the max content width. Now, when there is no explicit width set on a flex item, which means that the width of the flex item as well as its flex basis is resolved to auto, the browser tends to use the content size as its starting point. So let's see what the Flexbox inspector can show us. I'm going to highlight this so you can see. So the initial size, which is the content size, is about 1024 pixels, right? And because there wasn't enough space, the browser shrunk it, given that the flex shrink value was 1, and this is the final size that we're actually seeing on the page. I thought this was a pretty useful visualization. Now, if we happen to have an explicit width set on this box, so I'm going to do this now. Let's do a width of, say, 200 pixels. This width becomes the starting point for the calculation. Now, in this specific example, because our flex grow factor is 0, there's no growing involved, and the final size ends up being 200. It's 198 because of the borders, right? But what's interesting is that if there is a flex basis value, so let's keep the grow and shrinks the same. Let's give it a flex basis of 300. You'll notice that even though there is an explicit width set on this box, because of the flex basis, the starting size for calculation becomes 300 instead. So knowing this, sometimes when you set a width and you realize that, wait, that's not the width I set, maybe it's this, maybe it's a flex item with an explicit flex basis set. Just something to take note of. So let's move on to this bit called Freespace distribution, because I want to explain the difference between having a flex basis of auto and a flex basis of 0. So again, I have two sets of 3 items, but this time exactly the same content for both. They have different flex values though. So let's go and see what's what. So for this first example, I have a flex value of auto on the box. So auto resolves to grow of 1, shrink of 1 basis of auto. For the second one, everything's the same except I made it grow by 2 instead of 1. For the final box, it's just 0 growth. So the other two, the two values of flex shrink and flex basis is the same for everyone. So in this situation, let me expand this. You'll notice that there is a free space, and this free space is being distributed in the ratio of 2:1. So I'm just going to highlight this here. So if you look at the diagram, it shows you the original size, which is about, let's call it 254. And because there was extra space, this item was set to grow, and the amount of space it was allocated is about 77 pixels. Now, if we look at the one with a flex grow value of 2, what you'll see is that it has double the amount of free space as compared to the first one. So that's the implication of using a flex grow value of double or whatever ratio you have between your flex items. So if you look at the final size, they're definitely not multiples of each other. Like this second box is not twice the size of the first. If you did want that sort of a scenario, that's when the flex basis being set to 0 comes in. So by setting a flex basis of 0, what you're telling the browser is that there is no starting width for each item, which means it doesn't take into account the content size anymore. So if you look at this box with this flex basis set to 0, all of the free space is up for grabs. So this, as we've established earlier in the content sizing page, browser is not going to break words, right? So it's going to shrink this column to its max, to its min content size, and then that's it. There's no free space here. So whatever free space that's getting distributed is the amount of space across this viewport, and all of this space is being allocated to these two columns in the ratio of 1:2. So that's why this first box, it's 324, and the second box is twice of that value. So this is the difference. This is the difference in sizing you can achieve with Flexbox just by changing the flex basis value. So depending on the end result you want, this is something to take note of, that you have options, and it will affect the size of your flex items. One more thing I want to talk about for Flexbox is the fact that you can use box alignment properties on it. So the ability to align items with the box alignment properties is also a very big plus. So this Flex Inspector also allows us to visualize the free space that is distributed for all the different values. So let's let's highlight this again. If you look at the flex overlay, like I said, outlines of flex items. What we're interested here for box alignment is all this free space. So box alignment properties were meant to be used across different layout models, even though for now they can only be used with Flex in Grid. What I really like about DevTools, and even though I'm using Firefox now, I'm pretty sure Chrome does this. It is the magic of auto-complete. So, you can kind of, even if you can't remember what each of these properties do, you can kind of just run through the keywords until you get the one you want. But anyway, what I'm trying to say is that there are numerous options that allow you to distribute the free space, not only the entire block of your content, you can even distribute space between your items. There are 3 sets of values for that, all prefixed with space. So we do have a lot of flexibility when it comes to distributing our flex items within its own container. So justify content lets us adjust flex items along the main axis, which is this direction that flex items are laid out. So it moves, like I showed in the example, it moves all the flex children within the container or disperses the extra space between them. If we change the flex direction to column, can't spell direction, and then we should give the container a height. Let's just give an arbitrary value, 45. So you can see that we can also change the direction that the content is flowing. So the main axis is now flowing from top to bottom, and the flex items move in this direction. I hope y'all can see my cursor instead. So what I mentioned was the main axis. What is perpendicular to it is called the cross axis, which is whatever is perpendicular to the main axis. So if you look at my items, they all suspiciously are the same height. This is because items are stretched along the cross axis to the full height of the flex line the moment you put on a display flex. But if we do any self-alignment properties, let's try align items. They immediately shrink to their original heights. So this behavior will also happen for grid items. One interesting value for align items is called baseline. And this is useful when you have something like my example here, where you have different font sizes, different line heights. You can actually use baseline to sort of align all the textual content across your flex items. So if you happen to have some sort of editorial design that involves these different flex items of different heights, you could kind of align everyone's baseline together just to make it easier to read. Have a container, flex container, that is a lot longer than the total height of your flex lines. For example, let me change this to something big. Let's try something like this. So you'll notice that there's a lot of these white spaces between your flex items. So there is an option for you to pack your flex lines together using align content. So for example, if I set it to start, it kind of packs away everyone to the top, leaving the extra free space at the bottom. So these are the box alignment properties that you have that you can use to align your items within your container. Now, moving on, can't talk about CSS layout without grid. So regardless of whether you've used grid in production or you're just trying it out for the first time, it's really helpful to have a grid inspector tool. So the most basic usage of laying out items with grid is setting the track sizes of your rows and columns. So the browser will automatically place items into the grid using a very well thought out algorithm that is defined in the specification if anyone is interested. But things being placed one after another, it's pretty standard behavior, you don't need grid to put things in order. But let's talk about this grid highlighter. Why not? So similarly, it also exists in the layout panel. And you have options. You can display line numbers. You can display area names. We'll talk about that later. You can extend lines indefinitely, which is great if you have multiple grids on the same page. So that's fun. So this basic example, I really like the syntax of grid, right? So if you look at it, we have display grid and then we set columns and rows. If there are three values in grid template columns, you see 3 columns. There are 2 rows, and I see 2 rows. So as a visual person, I appreciate this type of syntax. Like I said, nothing special about things laid out one after another. What's special about grid is how simple it is to manually place items in both directions. So since my favorite analogy for this is placing items on a chessboard, this example, it is what it is. This is a simple 3x3 grid. I'm going to find it, highlight it so we can see. Nothing spectacular. 1 container, 3 items. The properties which control the grid items, which contain chess pieces, are grid row and grid column. So this is where the ability to see line numbers comes in really handy. So if you look at the second one, I wanted it smack in the middle of the board, so I set the grid row to 2, as you can see here, 2, grid row 2 sets it here, column 2 sets it here, that's how it gets to the middle. If you look at the last one, grid row 3, grid column 3. So that's how we place items in the grid. So numbers, when it comes to more complex layouts, let's say, I don't know, if you have 20 columns, you're not going to sit there and count columns. Take a look at the grid number, boom, there you have it. That's why I think this grid overlay is super useful. Now, I mentioned this area names thing. So this is another feature of grid that I really like. So if you look at the syntax, it looks a bit like, why is it so complicated? It's actually not. It's just that the DevTools does smoosh the values together a bit. But what we can do after we've allocated columns and rows is that we can assign certain areas with area names. So how the syntax works is that there are a bunch of lines that I have here that are surrounded by quotes. So each of the quotes represent a row, and each of the values within the quotes represents the column. So because I have a 6x6 here, I must have 6 rows and 6 column values. Otherwise, the grid template, this whole piece of code is moot. With grid template areas is that we can modify the size of our grid items without actually changing the grid item code itself. So as you can see, after assigning grid template areas, I can assign each item to its respective area. So this one I say grid area owl, grid area mouse, grid area flamingo. But if I want to change the size of the cell, the area, I can do it directly from the grid template areas code, like so. Hope I don't type anything wrong, otherwise my code is going moot. Let's try this. There you go. So instead of 4 cells, mouse now only takes up 2 cells. Didn't have to change anything down here, only had to change it on the grid container level. So I thought that was pretty useful, especially when we're doing things like full page layouts where you do have to adjust the size of your elements depending on the viewport. You don't really have to go and find every single grid item and then code for its position depending on the viewport. You can isolate all your so-called responsive code only to the grid container. I think that's pretty useful. This last bit here, animating grid rows and columns, when I started talking about this, it was still early. It came out in Firefox 66. I think we're at 84 now. So this feature has been around for a bit. Not sure when the other browsers are going to implement it, but you can animate grid columns and rows. This had always been written into the specification. It just took some time for the browsers to ship this feature. Now, without DevTools, honestly, it might seem as if this chess piece is jumping the grid rows and columns. That's fake news, my friends. Can't actually do that. So this is a trick. There's actually only one grid item, and there is only 2 rows and 2 columns. Right, so if I scroll down to the keyframes, this is what's going on. You can actually animate the column size or row size, and that's exactly what's happening here. And I use the box alignment properties to assign the chess piece to the bottom right corner of the first cell, and that's what's changing. The background is fake. It is a linear gradient. What is fun since I first started giving this talk is that Chrome has recently joined the Grid Inspector tool party. So if you are using Chrome, inspect. I have good news for all of you. I'm on Canary, so this is taking a while. There is also a grid inspector in Chrome now. So the advantage of this is it's almost feature parity with Firefox in terms of usage. So you go to the layout panel, and you can see they also allow you to show area names, line numbers. They have this thing called track sizes that's printed directly. To be fair, this is a new feature for Chrome, so clearly there are some bugs and rendering issues that need to be worked out, but the fact that they've shipped this means they're going to have to keep improving it. So if you really love using Chrome, well, good news, Grid Inspector is shipped. Hopefully they'll start shipping the other layout tools as well, so everybody will have a good time doing CSS. Moving on. I want to talk about this concept called flexible sizing. It's a pretty big thing when it comes to grid, and it's actually a fairly interesting new aspect of building modern CSS layouts. Because when we used to talk about lengths, CSS lengths, we use relative units like percentages or even the newer viewport units. That's all fine and good for responsive design, yes. But the problem is that they make all of your elements change size at the same rate. So when we use CSS Grid actually does introduce a lot of new features. One of the things is this new unit called the FR unit, which is the amount of free space available. It also introduces this MinMax function, as well as there are other intrinsic sizing values like fit content that we covered. We also have auto, which has been around for a while. And all of these different values, they don't change at the same rate. So I'm going to explain this with these visual examples on the screen. So all of the sizing units that I just talked about are supported in Grid. So all of these examples naturally are Grid. So there's going to be a lot of browser resizing coming up. I mean, the alternative talk title for this presentation is, what do you mean you don't size your browser 1,000 times a day, right? So it's going to have a lot of examples. Let's look at this first set of 4, which covers FR and auto. So FR is green, auto is blue. For FR, I have set the value 1 FR, 2 FR, and 1 FR, just to make a distinction that with FR, you can actually explicitly state how much free space is being distributed. So the first and third are half of the second box. That's because we set it that way. Auto behaves rather similarly to FR if it's used in isolation. So everything, if I have 3 boxes, I set them all to auto, they all have the same width. Cool. Now, when they're used together, you'll see that FR will take up any extra space available. So if there's lots of space in the viewport, all this extra space goes straight to the green box, which is sized with FR. But when there is no space, so when I start shrinking the browser, it's also the first to get space taken away. And as I take away more space, you'll notice that the blue boxes don't change. They are always fixed at max content when all this like space stuff is happening with the green box. So it's going to continue shrinking until the FR box hits min content. So the moment it hits min content, that means green box has shrunk as much as it could. And then space starts getting taken away from the blue boxes. Ultimately, when there is absolutely no space left behind, all three boxes are going to end up exactly the same size. But they did not change their size at the same rate. So I'm going to cover fit content versus MinMax. I think this is a fairly interesting comparison to make. So fit content and MinMax, they do behave quite similarly in that they're both a range of values with a minimum and maximum value. So MinMax takes two arguments, the first one being the minimum size and the second one being the maximum. We've already talked about how fit content works earlier. So let's look at example 5. We have an FR box, an auto box, and a fit content box. If we start losing space, so like this is maximum space, so green clearly has lots of room to work with. It's also the first to shrink, so we're going to keep shrinking it. You'll notice that fit content and auto end up reaching their minimum sizes at the same time, even though their behavior is slightly different. The comparison is more apparent when we look at example 6. So now we still have a blue box that is sized auto, but we have this MinMax yellow box, gold box, whatever, right here. So things are starting to get a bit interesting because when the column grows or shrinks is different. So again, I'm just going to start off with something that has a lot of space. Auto gets all the space when there's plenty of it and gives up that space when the viewport starts to shrink. Once auto hits its max content size here, it's going to stop shrinking. It's going to keep its max content size. The next box to start shrinking is actually the gold box, the MinMax box. So you'll see MinMax starts to shrink. And as we keep going, there's one point where everybody starts to shrink together. Exactly where, I can't say, but this is the point that allows all three of them to end up hitting their minimum size at the same time here. Okay, here-ish. So these two will end up being min content, while MinMax will stop at 200. So all of them hit their respective minimum sizes at the same time. So when there's a lot of space, the fit content gets capped at its max content width. In this example, I set it to 200, while auto and MinMax continue to grow. So this is about the point where it hits almost 200. And then when auto reaches its max content size, it stops growing, and then the MinMax box starts to grow, hits 400, then stops, and then blue starts to grow again. So what I'm trying to demonstrate in these examples is the fact that we can actually have our elements kind of wait for each other. So you might be thinking, sure, colored boxes are cool. How do I use this in real life? Really glad you asked. So I have two examples here. It's kind of I feel this is a design that is not uncommon. You see this on feature articles, feature stories. You have a big, nice image. You have a title stylized. So both of these look very similar at a full viewport with things start to become apparent that they are sized differently once the viewport starts to get smaller. So the first example, I've used percentages to size the elements. And at a small width, I'm just going to shrink this, you'll start to notice that because everything is shrinking at the same rate, because these are percentages, the image is becoming too small, the text is kind of like not set nicely, it's a bit too squished up. That's because everyone is shrinking at the same rate. So in order to tackle this, you probably have to add a breakpoint somewhere and rejig the percentages. So you can see what I've been setting. I've set it at 65% and some other percentages. There's this awkward margin top thing here too. But the second example doesn't suffer from this problem because I've used all these flexible variable sizing units that we talked about in the colored boxes example that allows us to have a more robust layout. So even at a tiny viewport width, I don't have to write any extra breakpoints just to deal with this situation. So I think that's a pretty interesting implementation of this flexible sizing that I talked about. Now, even though CSS properties seem pretty powerful on their own, I think we've demonstrated through display grid, flex, etc. There are a lot of CSS properties. I think there are over 500 the last I checked. And CSS kind of makes magic when all these individual properties are combined in creative ways. Because grid allows us to do things like overlap much easier than before. So if we combine, so it's not just layout, right? If we can combine a layout CSS like grid with things like, say, blend modes or masks or background clip, CSS shapes, etc., we can do some really interesting things. This is just a very rudimentary example using mixed blend modes and the variable sizing for my columns. But I can only imagine that those of you with a creative streak can come up with so much better than what I've done so far. But there's so many possibilities for much more creative expression on the web right now. So to wrap up, I just want to say that CSS is evolving, it's becoming more powerful. A lot of the older layout hacks are no longer necessary because we have these new layout properties that are designed specifically to suit the dynamic nature of the web. And with them come new concepts to be learned. So hopefully what I've covered, hopefully you start using some of these DevTools features to help in your understanding. And I guess I just want to round up by saying that if you've been on the fence about trying out these new features, I just want to say, just do it. It's not as scary as you think. Thank you very much.